So here we need to find out the minimum distance from the eye at which a coin having a diameter of 2 centimeters is placed so as to completely hide the moon. And it's also given that the angular diameter of the moon is 31 arc minutes. Now let's try to understand the problem. So here we have our moon and we have an observer E. So here the angular diameter of the moon is given as 31 arc minutes. It means that if we consider E to be the center, then the angle subtended at the center by the moon is going to be 31 arc minutes. Fine. So since it's an arc minutes, let's try to convert this angle to radians first. So here we have 31 arc minutes. So our goal will be to convert it to radians. So here we're going to use the fact that if we have 60 minutes, so this becomes equivalent to 1 degree. So that means in 1 degree we have 60 minutes. So in 1 minute we're going to have 1 over 60 degrees. Since we have 31 minutes, so 31 minutes is going to transform to 31 over 60 degrees. Okay, now what we'll do, we'll try to convert the degrees to radian. For this we use the transformation 180 degree that corresponds to pi radian. So 1 degree is going to correspond to pi over 180 radians. Now we have 31 over 60 degrees. So this will become pi times pi over 180 multiplied to 31 over 60. And this is nothing but 31 pi divided by 10,800. So this entire value is now in radians. So we have converted our arc minute, which is 31 minutes, 31 arc minutes into radians. So that's 31 pi over 10,800. So we'll come back to this in a moment. Now in a problem, it's stated here that we have a coin. So let's say this coin, we're having a diameter of 2 centimeters, is r distance away or in front of the eye, such that it completely hides the moon. So our goal will be to find out the value of r. So here we're going to use the fact, we know that the angular diameter, that means the angle theta, which is the angle subtended at the center, whether by the moon or by the coin in this case, doesn't matter. So this will be defined as the arc length divided by the radius. Fine. So since we are going to consider the coin here, so for here we need the arc length. So here we will suppose that the diameter is equivalent to the arc length, means it's approximately equal. So here we will say let the arc length, let's say this is approximately equals to the diameter of the coin, and it has a value of 2 centimeters. We're going to use that. We're going to substitute all this value here. So theta, we obtained that is 31 pi divided by 10,800. So that's the value of theta. We have the arc length, so that's 2 centimeters. We have the radius r. Solving for r, we get r value equals to 2217.9 centimeter. And if we convert it to meters, we'll have to divide by 1000. So we'll have r equals to 2.2179 meters. So here we see that this corresponds to option number D. The option D is going to be the distance. So that means the coin must be placed approximately 2 meters in front of the eye so as to completely hide the moon.